LeetCode 125, valid palindrome. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if S is a palindrome, false otherwise. This is a pretty nice description. They pretty much tell you how to do it, how to solve the problem. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backwards. The first thing we need to do is convert everything to lowercase, and then the next thing is to remove alphanumeric characters. On second thought, it doesn't matter which order we do those things in. In fact, it might make sense to remove the non-alphanumeric characters first and then convert everything to lowercase, since converting non-alphanumeric characters to lowercase would kind of be pointless. I think a lowercase dollar symbol is still a dollar symbol. Example 1, S equals a man, comma, a plan, comma, a canal, colon, Panama. Output is true. Explanation, convert everything to lowercase, remove all the spaces and all those non-alphanumeric characters, and it's a palindrome. A man, a plan, a canal, Panama. A man, a plan, a canal, Panama. Same thing backwards. Example 2, S equals race a car, output is false. Race a car is not a palindrome. Alright, but race car is, as we see over here. So example 3, S is the empty string, return true. S is an empty string. After removing non-alphanumeric, yes, we remove the space character and we have an empty string after that. I skipped ahead. Since an empty string reads the same forward and backward, it is a palindrome. Alright, so in my example 1, we've got 3 character sequences. I'll call them words. Redder is a palindrome, and I'm going to walk you through this stepwise. And we're going to check the characters using the 2-pointer approach. So we have a pointer to the first character of the string and the last character. Remember, the last character of the string is length minus 1. So redder has length of 6. The last character is 6 minus 1 is index 5. So our first pointer points to the start of the string. Our last pointer points to the end of the string, the last character in the string. And we compare those two, and if they're not the same, the characters in those indices are different, we're going to return false right away. And we're going to continue this pattern. So we check the first character to the last character. They're the same. So now we're going to increment our first pointer to index 1 from 0 to 1 and decrement the last pointer from 5 to 4. Okay, so we increment the first pointer and decrement the last pointer. So now we're comparing the character at index 1 to the character at index 4. They're both letter E. So that passes, it checks. So now we do the same thing. We convert the character at index 2, our start index, to the character at index 3, our end index. D is D. They're the same. It checks out. So now we're going to increment our start pointer to index 3 and our end pointer to index 2. That is going to be our loop terminal condition. When start and end overlap, we're done. And in this case, end is 2 and start would be 3, so that means we're done. And we're going to return true because we didn't return false. So we're just going to return true by default. We've made it that far. It's a palindrome. The next word we have is emisme. So we start out with index 0 for our start and index 5 for our end index. The characters check out. E is equal to E. We increment start to 1, end to decrement end by 1 to index 4. Character at index 1 is M, and character at index 4 is M, so that checks out. Okay, so we continue on. Increment start index to 2, decrement end index to 3. Now we have to compare I to S. I and S are different characters. so we're going to return false. Okay, and then finally we have a different setup. Now we have a configuration where we have a different type of palindrome. Notice this palindrome has an odd number of characters, whereas in the examples above we have an even number of characters. And in this palindrome we have a slightly different treatment for our middle character, E. So R checks with R. We increment the start index to 1, to decrement the end index to 5. A checks with A, still a palindrome. Increment start to 2, decrement end down to 4. C checks with C, increment start to 3, decrement end to 4. And we're comparing E to E. It checks. Now we increment start to 4 and end to 2. Now start is less than end. So as long as start is not less than end, as long as start is not less than end, we're going to continue. Or so we can say as long as end is greater than start. As long as end is greater than start. Because if end is greater than start, we can get to here, and then we get to this index. 3 and 3 are equal, so end is not greater than start. So in that case, we could actually terminate. So if end is not greater than start, we can terminate. Okay, so looking at the code, get this in screen here. I want to got our function here as an arrow function, strict mode, and we've got a regular expression here. Let's explain this nasty looking thing. It's really not hard. This is a negated character set in regular expression. That means start of the string outside of a character set. The square brackets indicate a character set. So inside this meta character has a different meaning. It means negation. So anything that's not lowercase a to z character range, not uppercase a to z character range, not 0 to 9 character range, global flag, we're going to replace with the empty string. That replaces all our non-alphanumeric characters with the empty string, resulting in the same string minus those non-alphanumeric characters. So that's assigned to V. We're going to loop through V from I is 0. J is V.length minus 1. As long as I is less than J. Now we could even change this around. So we could say as long as J, we don't have a not greater than. We can say J greater than I. And then we can avoid the check for the middle character. For the race car example, we don't have to check E against E. But I find this syntax to be a little unfamiliar. It just doesn't, it's not something I usually use. So I'm comfortable with checking E against E for one extra iteration. That really isn't going to make much of a difference at all. Performance-wise, it's going to be negligible. And so what we're going to do in each iteration is we're going to check to see if the character at start is equal. If it's not equal to the character at the end index, we return false. And we're going to continue doing that until we're all done. And if we've completed this series of characters in the string and we didn't return false, then it's a palindrome, in which case we return true. Okay, so that concludes the lesson on LeetCode 125 is palindrome, and this performance I got is pretty good. I tried it a different way before, and coming back to it, I reread the instructions, and I realized that it was actually faster to do this check inside the loop rather than doing a more convoluted loop with testing to make sure that we're ignoring, which is the way I was doing it previously, which was not a very smart way to do it. So this is the way I was doing it before, just ignoring, making sure that we were comparing alphanumeric expressions and then incrementing and decrementing I and J respectively, which is a much more convoluted way to do it. It doesn't make sense to do it that way. This is simpler, and it actually performs much better. It's really good performance. So that concludes the lesson. Thanks very much for watching.